computing, and everything that goes with it is dramatically changing the roles and aspirations of IT administrators. Moving to a cloud data environment frees up DBAs from day-to-day operational tasks and provide more time to work directly with business leaders and customers on ways data can be applied to business problems. Chances are that you must have heard this exposition multiple times in the last few months. And while it may have sounded unnerving to a few because it indicates the blurring of boundaries, while it may have sounded exciting to others as it widens the scope of IT admins' roles and responsibilities, you must have wondered at some point what exactly are these tasks, activities, and responsibilities that you need to take on when your organization moves to AWS Cloud. Hello, my name is Anuja Malik. I'm a Senior Database Specialist Solutions Architect here at AWS. In today's session, I'm going to break down the roles and activities that the new age DBAs perform for running their databases in AWS. Before the cloud, companies would typically have a team of database administrators, the DBAs, and database specialists with one mission: to stand up and maintain the chosen database solution for the entire company. It really used to be a platform choice. You would consider 2 or 3 vendors, you would pick one, and that would be your platform, and you would start building all your applications on that particular platform. The DBAs who work with that chosen database developed deep expertise in the management and maintenance of that particular database system. And since they have invested significant time and money in the solution, they would use it for every workload, even when there may be better options available. In cloud, the approach is flipped. You start thinking from the application perspective, because not all applications are built the same way. What are the application requirements for your specific use case? How many users will connect to it? How will they access it? Where are these users located? If you think about some of the largest cloud applications, such as ride-hailing, media streaming, news applications, social media, dating applications, you will notice some common characteristics. They all have millions of users. They are located all over the world. Everybody is expecting a near instant experience, which translates to predictable sub-milliseconds performance. And these systems, they need to scale on the fly. So this whole idea of one size fits all database, that doesn't really work anymore. You need to find the right tool for the right job. Now, developers today are no longer want to compromise on functionality, performance, or scale. They want to build a top-notch application worthy of their competition in market. And to do that, they don't want to be bounded by the limitations of any one particular database platform. So, what does it mean? So, how does it affect the database administrators? Businesses today don't need just a database administrators, but they need data engineers who have knowledge in terms of data security, choosing the right platform, and keeping it cost effective, who can analyze your workload and recommend what should be your database strategy. Also, very importantly, moving to cloud is not a single-step process. It's never going to be all or nothing. A lot of customers move to AWS in phases. And what that means is that they are responsible for assets in a hybrid environment. Right now, if you can picture, you are now responsible for managing databases, which are in different flavors, that is, different database engines. They are running across different geographic regions and oftentimes in a hybrid environment. Few are on premises and few are in cloud. That definitely calls for a database engineer who can maintain a visibility into these diverse systems and knows about the best practices for each variation that drives optimal performance and is cost effective. So you're not responsible for just one database, but the entire data platform. Especially in enterprises, DBAs are essentially providing data platform as a service to their businesses. And therefore, they fulfill critical functions such as coordinating and executing releases and monitoring the data platform after a release to ensure it continues to perform. DBAs today also play a key role in DevOps, particularly the application development and deployment process. Now, DBAs are strategically aligned to contribute to the DevOps transformation because their administration role gives them touch points in both development and operations. They have a solid understanding of how databases work and how to operate these optimally. More and more DBAs are participating in designing, coding, and testing database objects like stored procedures and packages. And that's how they are contributing to application development. And last, but definitely not the least, I would say that the number one skill that DBAs need to master today is the database migration. As per Gartner, the worldwide public cloud end user spending is expected to grow by 18% in 2021. That translates to about $304 billion. The report also says that the pandemic COVID-19 validated cloud's value proposition. So what this means is that more and more organizations are moving to AWS. And therefore, as an IT admin or a DBA, the best way to contribute to your organization's success is by leading these migrations. Now, migration is a big, broad topic in itself. There are multiple migration strategies. Which one to adopt, how to make that decision, and more importantly, how to cause minimal disruption for your business and your end users. That should be the biggest focus for today's IT admins and database teams. Moving on. Now, the role of the traditional on-premises DBA typically includes of the duties and responsibilities that can be grouped into 5 management categories: application, access, database, monitoring, and platform. From what we have seen, and even with my own experience as a DBA, one ends up in spending all the time in keeping the lights on. We get caught up in day-to-day infrastructure operations such as troubleshooting hardware issues, root cause analysis of failovers, and all year-long patching cycles. Any proactive tuning and application improvements generally take a backseat to the day-to-day managing of the database itself. Amazon RDS flips your role as a DBA around. So you spend only a fraction of your time on routine management tasks, and this leaves the rest of your time for aligning your work more closely with your business. You can focus on lending your DBA skills to application teams and end users, helping deliver new features, functionality, and proactive tuning value to the core business. As promised, let's take a closer look at each one of the categories and the areas of focus for cloud DBAs. Platform. So, one of the most crucial as well as time-intensive activities for DBAs is to set up a highly available architecture with minimal RPO and RTO. That is recovery point objective and recovery time objective. In AWS RDS, when you provision a multi-AZDB instance, high availability is built in. It automatically creates a primary DB instance and synchronously replicates the data to a standby instance in a different availability zone. Now, this availability zone, or for the matter of fact, any availability zone, each availability zone runs on its own physically distinct independent architecture and is engineered to be highly reliable. In case of a failure, RDS performs an automatic failover to the standby or to the replica so that you can resume the database operations as soon as the failover is complete. This, perhaps one of the most important functionality of your database architecture, no longer requires an enormous amount of investment in setup and management on the part of DBAs. And that is across all the database engines. And that's really the key. With Amazon RDS, DBAs don't really need to learn from scratch about how to install a database, how to configure high availability, how to take backups, etc. And that is why more and more DBAs are expanding their area of expertise and are able to support a wide variety of database engines. The way DBAs are revolutionizing platform activities is by automation. Whether using PowerShell, Python, AWS CloudFormation templates, or AWS CLIs, whichever is your favorite choice of tool, you can really streamline your deployments, standardize according to the environment, that is production, dev, or QA, and most importantly, reduce the turnaround time for building database instances from hours to minutes. Also, the DBAs have stepped up to improve the RTO and RPO for their organizations. With features such as Amazon Aurora Global Databases, it is now possible to have a solid disaster recovery even across multiple regions. DBAs are making use of these features and functionalities and automating the disaster recovery drills frequently to ensure that their DR plan is up to date, fail-safe, and meets the compliance requirements. Here you will see a code snippet to create a new RDS DB instance. With just these few lines of code, you can set up a highly available, highly secured database instance as per your standard configuration. And this is just one of the activities that can be done using the CLIs. So talking about security, as we always say that security is the shared responsibility by AWS and the customers. Now, AWS provides some very strong tools to secure your database architecture. Tools such as AWS Secrets Manager, CloudTrail, and AWS Key Management Service, KMS. We still need DBAs to make use of these tools and solidify the security of your database instances. One simple example is, as a best practice, it is recommended to log not just the failed login attempts, but also the successful login attempts to your database. However, it had been a huge challenge in the past because how do you even store such a large stream of data? You need storage for that, whether it is a disk, drive, or any other storage. And even though if you are able to store, how do you read through such a large data set if need be? With AWS, DBAs today leverage S3, our simple storage service, to store these kinds of large data sets, such as successful logins. And using Athena, you can access S3 data using simple SQL queries. I also want to show you an example. Now, in this example, you see that how we can integrate Git webhook with RDS database instance. With a webhook in place, each time a Git user pushes a commit, your repository is automatically retrieved, zipped, and uploaded to an Amazon S3. You can then configure your AWS services such as RDS, code pipeline, code build, and even code deploy to use the S3 as a source. Monitoring and performance. Once again, because there is a managed database service, you really don't need to write your own scripts to monitor database instances. You can use RDS events to get notified of any database instance level activities, such as if your database instance goes down, or whenever a failover happens, or even when someone changes the configuration of your database instance. DBAs today can build powerful monitoring strategies based on these tools, that is, RDS events and CloudWatch. And what's more useful is that you can have a common monitoring strategy across multiple database platforms. You can write SOPs, standard operating procedures, based on those events and what actions your teams need to take in case that those events happen. It gives you an opportunity to centralize your administration in a very easy and efficient way. Also, using tools such as Performance Insights, DBAs are taking up more and more proactive tuning activities. These activities, as I referred to earlier, often used to take a back seat due to DBAs spending most of the time in keeping the lights on. However, with RDS, the underlying infrastructure is well taken care of. DBAs can bring out their database expertise to fine-tune the queries and improve the overall performance of databases. And it also has an impact on the cost, a huge impact. One specific example is that In your on-premises environment, you would provision your database instances keeping the maximum usage in mind. So let's say that you are aware on an average the database needs only 8 vCPUs. However, for certain end of the month activities or for reporting purposes, the CPU usage can go up to 14 vCPUs. Using RDS, you can leverage the scaling feature to scale up your database when there is a demand and scale down when that much horsepower is not needed. Not only that, a very common use case, a lot of time my customers tell me that they need to over-provision to account for the CPU spikes that happen from time to time. And these spikes can really slow down the performance for their end users. Using CloudWatch metrics, you can get, first of all, notified when the CPU spikes happen, and using Performance Insight, you can easily do a root cause analysis of CPU spike, because it can tell you which are the top queries or the top users or even the top hosts from which are causing these spikes. Imagine all of this information without having to write your own custom scripts or figuring out where to store this information or how to access this information for every database instance. All right, again, one of the key DBA activities is to manage and administer the database configurations. Now, RDS gives you a very strong administration ability in form of parameter groups and option groups. Using these two features, you can standardize your configurations across a large database estate. You can control these configurations from a single point. You can push any configuration changes to a bulk of servers. You can implement a strong change management process for making any changes to your database configurations. And very importantly, you can audit these configuration changes across all your databases. No more digging into the details of who made what changes to your databases. Because using the parameter and the option group, all the changes can be tracked and audited. And lastly, using the parameter and the option group, you can even categorize your configuration as per the environment. That is, you can have a different set of configuration for production servers, for dev servers, and for QA servers. Sometimes our customers also define the configuration based on the application requirements, such as L1 security, L2 security, all the way up to L5, where every configuration has a different set of security requirements. So yes, DBAs today are focusing on sophisticated administration policies on how they can make use of these features to streamline database configurations. So as I alluded to earlier, using RDS, more and more DBAs are contributing to overall application architecture. DBAs can offer on ways to automate database deployment. They can automate change management and suggest optimizations. For example, DBAs can review the performance insights data and recommend to, let's say, use RDS proxy if it is needed to remove the performance bottleneck. They can also suggest archiving strategies using S3 or Amazon Redshift to keep their database performant. By looking at the data access patterns and performance utilization, DBAs can also recommend on scaling requirements, such as adding a read replica, right? The key is that with AWS, there are so many native tools and out-of-the-box functionalities to leverage that DBAs are able to experiment more with databases and be agile with their customer demands. And this rightly leads me to my next segment, which is innovation. Now, AWS iterates quickly. We are launching new services, new features, and functionalities every often. And we need the IT administrators and the DBAs who can keep up with this innovation and who are constantly integrating these new launches into their architecture for the betterment of their environment. DBAs, they are playing a key role into breaking down a monolithic architecture into several microservices. They are in the forefront of advising when to use a relational database, when to use Amazon Redshift for analytical workload, and even when to use AWS Lambda to interactively run a code or decouple tasks from a relational database platform. Some organizations are even encouraging partnerships by integrating the DBAs with their data science team. Since DBA is a very tenured role, and with that comes the domain and the industry knowledge, so one of the benefits of embedding the DBAs with the data science team is that or even with the BI and the analytics team, is the ability to leverage both the DBA's domain knowledge and their mastery of data movement within a company's environment to put a proper context around a data scientist's analysis of both structured as well as unstructured data. With that, let's take a look at a quick demo to see a few key RDS features in actions that we talked about in this session.
As I mentioned earlier, that one of the immediate challenge that the DBAs are facing is that they are not responsible for just one database, but the entire data platform that includes multiple database engines. And DBAs need to evaluate how to manage these different database engines. When it comes to managing databases in AWS, you don't necessarily need to learn on how to install it or how to configure high availability from scratch, or for that matter, even how to manage backups for these different database engines. But one of the key things that you do need to understand is how to have visibility into these databases that you're responsible for, or let's say in simpler terms, how to monitor these systems. So AWS provides you a set of tools that make it easy for you to manage and administer these databases. Let's take a look. What I have here is my RDS console, and within my console, you can see that I have a variety of databases. Few are RDS SQL Server and few are Aurora Postgres Server. So the first thing that I want to ensure is that I want to be notified when any of the instance goes down, or when the failover happens, or let's say when somebody changed the configuration of these instances. Now, if I were self-managing these servers, then I would have to write my own scripts. I need to understand the database fully on how to track these changes, how to track whether SQL is up and running, how to track whether Postgres is up and running. In AWS, you can make use of events and event subscriptions. So what you can do is that you can create an event subscription. Let's name it as RDS event for production servers. And I can choose where I want to send my notifications to. This basically makes use of simple notification service. And then I can choose that, do I want to receive alerts, events on my instance type or my parameter groups and security groups. For every source type, you would see that there are certain categories. For example, for instance, I have a category for availability. I want to be notified when the database is not available or when the instance is stopped. I want to be notified when the failover happens. I want to be notified when somebody deleted the instance level, right? And as you can see that it includes all the instances. I can even choose my certain instances. Let's say I want to set a different profile for my production instances and a different profile for my dev instances. But what you would see is that it covers all the engines, not just one category of engines. And that's it. After I create these event subscription, if there are any events that happen on one of these instances, I can be notified of those. Now, this is the instance level events. What if I want to find out what's happening inside my databases? To do that, I use a tool called Performance Insights. Again, Performance Insights is a common tool that works across all database engines. So either I can choose a SQL Server and find out what's happening inside my SQL Server. I can choose which metrics I want to see. For example, I want to know how many active transactions are running. Are there any deadlocks that's happening inside SQL Server? What is the page life expectancy, the batch requests, and Performance Insight will give me a very thorough, detailed description of what are these metrics that I need to be aware of. It can also give me the top SQL queries that are consuming the CPU, or it can also tell me the top waits that's happening on my SQL Server. Again, I don't need to be a SQL expert to do all this. If it were not for the Performance Insight, then I would have to write my own queries, and I need to know SQL Server well enough so that I can write these monitoring queries and get the data that I'm looking for. And the same goes for Postgres instances. I can use Performance Insight to get the performance analysis for my Postgres server without having to write my own scripts. Let's take it one step further. So this all looks very good from a reactive analysis point of view. What if you want to set up some sort of proactive monitoring and you want to be notified of events that as they happen, and maybe you want to capture certain reports? In those cases, we rely on APIs that AWS provides you. So the same data that we are looking at, whether it is CloudWatch data or Performance Insight data, I can fetch that data by using the APIs, and I can extract any metric that I want. So this script will be available on the Git, and we will share the link with you. But essentially what the script is doing is that it is looping through all my database instances. As you can see that irrespective of database engine, it is looping through my instances. And what I'm doing here is that I'm storing a report on my S3 bucket, and that report shows me what has been the CPU consumption or the performance analysis for all my database instances. So this is the report. And as you can see, that this report gives me a very good, I can run this script at every, let's say, 30 minutes. And every 30 minutes, I can get a snapshot of what is the CPU spike, and did any CPU spike happen in the last 30 minutes? Was there any high CPU? What are the average DB transactions? How is the CPU utilization looking? So again, without having to write my own script and without having the deep knowledge of every database engine, I can use the existing tools that comes with AWS and use that for my advantage. Thank you.
It's an exciting time to be a DBA, with expanded responsibilities and opportunities to develop strategic business solutions with the development team. As such, it's a great time for DBAs and those looking to move into a role focused on database technology to seek training and hands-on education to help skill or upskill their expertise. Now, AWS Training and Certification offers extensive training, a database learning path, and a database specialty certification. If you are new to AWS databases, a great first place to start is our free digital course called AWS Database Offerings. In this self-paced and 5.5 hours course, you will get a basic overview of the AWS database technologies. It also covers the concept of purpose-built database, which changes the age-old one-size-fits-all methodology. I really appreciate you listening in for this session today. I hope you found it useful. I would request you to please take some time and fill in the survey for this session, because it helps us understand the value of these sessions for our customers, and we can come up with even a more curated content in future. Thank you again for listening.